Okay, so here we are. We're finally in day 3, or sorry, not day 3, but part 3 of the All Things Being Equal packet that we've been working through here. We are going to be looking at this piece of paper and the chips that are on it. There's 12 of these clear chips around the edges. There should be 12 double-sided chips that can be yellow or red, and this will help us represent the reaction that we did in part 2 with the iron 3 ions, the thiocyanate ions, and the iron 3 thiocyanate ions, and the colors that they represent. This is the packet that we'll be working through and the page that we'll be working through to begin with. Note that here is the chemical equilibrium equation with this sort of formula. You'll want to start filling out these questions as you progress, especially number 2. This one will be particularly important later on as we continue to go through this reaction. Over here, the first thing that we have to do is we have to set up the equilibrium for that reaction with the iron 3 ions, which are going to be yellow, the thiocyanate ions, which are going to be the clear ones, and the iron 3 thiocyanate ions that are going to be the red side of the chip. This reaction is known to be in equilibrium when there are 4 iron 3 ions, 6 thiocyanate ions, and 4 iron 3 thiocyanate ions. So I'll set that up on this piece of paper so that we can use this piece of paper to represent the test tube that we were mixing the things in earlier. So I've set up this reaction, per se, in the test tube that is the paper with the 4, 6, and 4 chips to represent this reaction at equilibrium. One of the important things to do here is find the K equilibrium value represented here using the equation that you did in number 2. This will be particularly important. What I got is 1/6 just as the K equilibrium that you'll want to use for this reaction and later in the questions that you're working through in this packet. Number 8 is kind of an interesting question to look at here. It asks what color we think this would be because it's a mixture of some of the orange iron ions, thiocyanate ions, and the iron 3 thiocyanate ions. Because it's a mixture of equal amounts kind of the orange and the dark red that you've got going on, the best guess for what color this should be is like a reddish orange or somewhere in the middle, not as dark but not as light as the light orange. So it said to add 4 more orange chips, or the yellow in this example, and 2 more of the colorless chips, and in the table write the numbers that you have. So I have 8 total orange chips, 8 colorless chips, and 4 red chips. Then you'll need to find the K value using this test tube that we have going on here and determine whether or not it is in equilibrium and explain why or why not. Also, does this have too many products in it, or does it have too many reactants? Which one does it need in order to become more like equilibrium? That's another important thing to look at as we go through this lab. Number 13 here asks us to rearrange these ions, you could say, in order to get back to equilibrium. Using number 12, we actually know that we need more products. So to create the products, what we do is like this. We take a clear one and place it over one of the yellow ones that we flip over so that it looks red again. For number 14, this actually reaches equilibrium when there are 6 of these individual clear ones, 6 of the yellow ones, 6 of the red ones, 2 of them being made as products of a yellow and a clear one together. 15 asks you to predict what color you would imagine this to be, and then complete number 16 as well, using what you know from there. Number 17 is about removing the ions from this system. So it asks us to remove 2 of the orange ones, which are yellow in our example, and 4 of the clear ones, like so. Again, you need to calculate the ratio and compare it to your equilibrium constant. That ratio, again, comes from question 2, that K equals equation, and determine the ratio. So my ratio that I found was 3/4 for this one, for example, which in question 19, once you get to question 19, you need to figure out whether or not that means you need more reactants or whether or not you need more products. Here again, you need to re-establish equilibrium is what question 21 asks you to do. So you know that it's in equilibrium when that ratio, again, is 1/6, like it was earlier on the first time we did it. So here, this one reaches equilibrium when there are 6 of the orange ones. These products are going to disassemble again back into reactants. So there's 6 of these orange ones, 4 of the red ones, and 4 of the clear ones. Now the products can be formed or taken apart because this reaction is reversible. That's one of the most important things to note here. The fact that you can make the product if you need to reduce the number of reactants, or you can break apart the product if you need to increase the number of reactants. That's a pretty important thing to note here. Now predict the color here. There's slightly more of these yellow/orange ones, and this will tell you something about what you do when you need more reactants versus the more products one that we exampled in the first time. From here, you'll be able to go on to some summary questions, just making predictions about what you think would happen in other reactions sort of similar to this. And that is actually the end of the all things being equal packet. I just flipped to the last page and was kind of surprised myself. But I'm glad that we were able to do this, and I hope that you were able to learn something through this packet.